Linear equations. We're starting with homogeneous. Right, so remember, homogeneous means what? Equals 0. Derivation is for the second order, but it can be extended to orders larger than 2. So a few important things to note. Again, for the most part, I'm going to let you read through these on your own. The auxiliary equation. So when solving homogeneous linear, first you want to set up your auxiliary equation. And remember, with root, you have 3 possibilities. It's either a distinct root, a repeated root, or complex. In the case of distinct, your solution is that form. In the case of repeated, that's your solution. In the case of complex, technically that's the solution, but we want real valued functions. That's a complex valued function. So we make use of Euler's formula. To get that as our general solution for complex. Generally speaking, set up your auxiliary equation. Your root n has a multiplicity of k. What is multiplicity mean? What's the multiplicity?
It's like repeating. Or
The number of times that it repeats. Right, generally speaking, the factors of that form. We'd say R is a root multiplicity n. Then that one root will contribute all of these solutions. And if it's a complex root of multiplicity, what would we say, k, contributes 2 terms. Now all the derivations out of the way. At this point, you really just need to know algebra. First, set up the auxiliary equation. M squared minus n plus 2 equals 0. Solved. Solving quadratic. You can always use quadratic formula, right? But generally, it's easier if it can be factored. Can that be factored? Oh, that should be a minus 2, sorry. I don't know why. Well, plus. That can't be factored. What is it factored to?
-2 plus 1.
You get solutions of either -1 or 2, right? There's your solution. C1 e to the negative x plus C2 e to the 2x. And obviously then if you had initial conditions, you could find your C1 and C2. First, set up the auxiliary. What's the auxiliary equation for this one? Sure? Confident about that? How confident? Because it didn't sound like you were confident. It sounded like you were asking. Make it interesting. You're in a dark alleyway. Guy comes up with a knife, asks you if that's your auxiliary equation, and if you're right, he lets you walk out. If not, you're getting shanked. You walking out of there? That's not very good. Yeah, you're walking out. That's the auxiliary. Don't overcomplicate it. Right? That's easy to solve, right? You should easily be able to see what the solution is. You get either 0 or 7. What's 0 times x? What's e to the 0? There's a general solution. Auxiliary.
M squared minus 5n.
Is it this?
N squared minus 5 is 0.
Why is it just minus 5?
It's just y.
It's just n squared minus 5. Now that makes that also really easy to solve. What are your two solutions for n?
What's the minus 2? Oh, sorry.
Root 5. What's your root?
Negative root 5 or positive root 5? That would be your solution.
Does it matter if it's like the negative 5 is on this C2? So,
Order doesn't matter. I typically like to write it in ascending order, but it doesn't matter. Really testing your knowledge. Who remembers the fundamental theorem of algebra? Oh, you're out of the teacher. Very sad. Very, very sad.
Is it a squared plus b squared, not that?
Question? Any nth degree polynomial can be written as a product of linear factors, where where each C is a complex number. A corollary of this is if you have an nth degree polynomial with real coefficients, if you account for multiplicity, it will have exactly n roots. Oh, good. The auxiliary equation for a linear equation, isn't that an nth degree polynomial? Which means accounting for multiplicities will have exactly n roots. That means your solution, your fundamental solution set will have exactly n terms in it. And so your general solution should have n terms. Two terms, two terms, two terms, and they're all second order. It's kind of a good way to check. If I actually solve a fifth degree linear equation and you don't have 5 terms in your general solution, you get something. It's the auxiliary equation here.
M squared plus 10m plus 12 equals 0.
It's 10 plus what?
Plus 21, sorry.
Can that be factored? I guess the correct question is it's always going to be able to be factored. Can it be factored simply, I guess would be the correct one, using integers? Yes. What are the factors?
7 and 3.
Easy to say, you get -7 or -3. What's the independent variable? And as a general thumb, prime, if it's y prime, it will mean x as your independent. It's the auxiliary. What are your two solutions? Which is what? What's square root of 0.01?
0.01.
What is it?
No, never mind.
What was it?
I said 0.01.
What did you say?
Uh, 1/100.
Well, that's what 0.01 is. What's the square root of that? It's 0.1. Taking square roots of decimals is generally easy. And this is going to be what? X of t, right? How easy this is. For homogeneous, it actually doesn't get harder. Especially since you can just use a calculator to solve the roots of your polynomial. So you don't have to worry about, oh, it's the 7th degree, I have to go through all that bullcrap we did in pre-calc. Of the use Descartes' rule of signs, find all the rational zeros, test whether it's a zero or not using synthetic division. Now I have a 6th degree. Do the same thing. No, you don't have to do that, just use a calculator. So these should take you like a minute. When it's not homogeneous, that's where the fun begins. Oh, I only have a minute left. So we'll just pick up here on Thursday. Second group assignment's up. So we're going to take a look at that. Second, homework journal will be collected on the day of the second exam, which is July 24th. Also, keep your eyes on Teams messages. depending on how tomorrow goes with the heat, we may hold class virtually on Thursday. I'm already getting sick from the heat. Pushed myself to come in today for the exam. So I'll let you know Thursday morning how I feel. If I'm going to do it virtually. If you get nothing, then it will be virtual. So just keep your eyes peeled for that. Stay cool. Don't go outside unless you absolutely have to, because I think I've said this, these two. This is a cold day for hell, but it's still hell. I'll see you guys.